Hello and welcome to this week 11 DS session in traffic engineering. So I'll wait for 5 more minutes to see people join in this session and then I'll get started with today's content. So it's 7:05 already, so I'll get started with today's session. So more people will join in later in this session. So welcome to this week 11 TA session on traffic engineering. Today's topic of discussion is parking management as well as traffic safety. So we'll look at some of the similar problems that you'll find in assignment 11. So that's the agenda. And the content is, I felt, was fairly straightforward this week as well. So let's get started with this session. I'll turn off my video and share my screen. Okay, so hope my screen is visible. Yeah. Okay, so to give you an overview of the topics that have been covered in this week, so I have mentioned first part is related to parking. So it's parking supply and demand to begin with. Then there is parking management. Then after that, I think it moves to the traffic safety part. So traffic safety. And within that, you will find different topics like road safety, and then like road safety engineering is one that I can tell you. And I think you will have black spot analysis. So these will be the topics that were covered in the session lectures, and this will be also the topics of discussion in this session. So first we'll directly look at some of the similar problems that you'll find in assignment 11, and let's see whether it's difficult or easy to answer. So hopefully you'll be able to answer those problems. So the first one is straightforward. It's saying state true or false. And it says parking supply surveys are useful in determining short-term parking demand. So this is from the initial portions of the lectures. I think it's from module probably H, yeah, it's H, I think H1. So the first lecture of that parking module. And so the answer is straightforward. This should be false because uh, so the thing that gives you the short-term parking demand, this determining short-term or long-term, is what is called as weak survey, not the supply surveys. So that's why it is false. So this was straightforward. Next, let me see whether to solve another this kind of problem or directly move to numerical. So let's quickly check. Yeah, so let's solve one more of this. So this was the first one. Another one is, suppose I tell you, if long term parking demand is less than equals off street parking supply, then the vehicles may be allowed to park to on straight facility. This is, I think, from the third lecture of this parking module. So there it is told that now if off-street parking typically occurs when you have this long-term duration of parking. So now this long-term parking demand, if it is less than equals off-street parking supply, that means your supply is adequate to cater to all those long-term demands. Then, if that is the case, then vehicle won't be allowed to park on the on-street facility because the off-street facility will be prioritized and it should cater all those demands. So that's why it is also will be false. So these two were pretty straightforward. Now let's move on to one numerical related to parking survey. So this is the numerical. So I'll give you the question and the data first, so you can take a look at the data for some time, and then I'll give you how to solve this. So it would be better if you can also solve this before me. That would be great. Now the parking survey data collected from a parking area for an hour. So this is at 15-minute interval, and this is by license plate method, shown in the table below. Now I'll give you the table, and each cell indicates license plate number of the observed vehicle, if any. Okay, so I'll give you the table now. So let me insert. It's 5 columns and 9 rows. Okay. Now I'll fill this table. So this will be a problem data. So it says, so this is your bay number. Then this is 0 to 15 minute, then 15 to 30 minute, 30 to 45 minute, 45 to 60 minute. So you have this 1 hour of data, and you have 8 bays here. So this would be 1, 2, 3, 4, 5, 6, 7, 8, and the license plate of the observed vehicles at every bay. Bay is a like space where one vehicle can occupy that position, or one vehicle can park at a certain point of time. Now this vehicle with license plate 1988 has been parked there for the 0 to 15-minute interval. For this 15 to 30-minute interval, this bay is empty, so there were no vehicles. For the second bay, this vehicle with license plate 2365 was there from 0 to 15 minutes. Sorry. So now this vehicle has left that bay. Another vehicle have come in with license plate 9874, and it was remaining at that bay for another 15 minutes after that as well. Then it left and another vehicle came in, which is 8554 with license plate. Now this bay 3 was empty to begin with, and then one vehicle came in, which is having license plate 3636, and this vehicle were occupying that bay for the entire duration. Similarly, I'll fill the rest of the table, so you have understood the meaning of these numbers in this table. So this is another vehicle that were there for 30 minutes at that bay. Then at bay 5, you have 1875, 1875. Then you have 2494 and 2494. So then you have this is as empty. You have 7686. This is also 7686. So next one is, these are again empty. This is 1498. And then this is 559. For this one, it's 1789, 789. This is also 1789. This is it. So this is the problem data that you have. Now you have to find a bunch of things. The first of those is, I'll write it here, and then maybe you can take a photo of this slide so that I'll solve it in the next one, next slide. But I'll write the question here. So the first thing that I'll be asking you, what is the average turnover? Or what is the average, like, parking turnover, whatever you call it. You can call it as parking turnover as well. Okay, so that's your first question for this problem data. Okay, the next question is also, I'll write down the questions here, that will be easier for you. So this would be, what is the average occupancy? This was also taught in the class. Third one is, what is the parking load? So you're asked these three questions. So you can start solving it. If you have gone through the lectures, then it should be very easy for you. You can tell me the answers, and I'll start solving it in the next slide. So I'll pause for a couple of minutes, then I'll get started with the solution. Average turnover is same as parking turnover, in case you are wondering, because that was the, I think, terminology that was used in the slides. And you will find all its definitions from the second part of this module, H2. And there also, I think there was an example problem related to this license plates. Shouldn't be difficult to solve. Okay. So let's get started with the solution. Maybe I'll just copy it, this table, in the next slide also. Okay, so this is your problem data. Now, first thing that you have to find is the parking turnover or average turnover. So for that, so this is the first one, average turnover or parking turnover, right? Parking in brackets. So from the slides, the formula for this is parking volume divided by number of bays available. So this is parking volume divided by number of bays available. From this table, you can notice that there are 8 bays that are available. Parking volume is also defined as total number of distinct vehicles parked in a parking bay or in a parking area during a given period of time. So this is the you have to then sum it up over all bays. So for the first bay, there is only one distinct vehicle that is available. So this is 1 plus for the second bay, there are this first vehicle 2365, then there is another vehicle 9874, and then there is finally another vehicle coming in which is 8554. So there are 3 distinct vehicles that are available there. For the third bay, it's 1. For the fourth bay, again, there is only one distinct vehicle. For the fifth bay, there is one vehicle, 1875, another with license plate 2494. So this is 2. For this sixth one, it is only one vehicle. For the seventh one, there are 2 different vehicles. And for eighth one, there is only one vehicle. So now this divided by number of bays, which is 8. That would be your answer. So here it's 4 plus 2 is 6 plus 2 8, 9, 11, 12. So 12 divided by 8, which is 1.5. So that's the correct answer. Okay. Yeah, 1.5 is the correct answer. Let's solve the next one. So the next problem is having the same data, but you are asked about average occupancy. So for that, let's write it here as well. So for average occupancy, so now the formula for average occupancy is sum of all the occupancy divided by total time intervals that you have. So in the slides, I think you will find it in one of the example problems. There, this relation is written: sum of occupancy of each time interval divided by number of time intervals. Now you have 4 number of time intervals, which is this 0 to 15, 15 to 30, 30 to 45, and 45 to 60. Now for all this, you have to find the sum of occupancy for each of these time intervals. Now, if you can notice, you have to now look at column wise. So you have 8 total bays available, out of which for the first time interval, only 4 of them are occupied. So your occupancy for that will be 4 by 8. Then you have for the next one, 5 of them are occupied out of 8. So I can write here as plus 5 because the denominator remains as 8. So I'll do that. Then you have for the next one, 7 of them are occupied, only 1 of them are empty. So this is 7. Then for the last one, you have 5 of them are occupied. So this is 5. Now you have divided by 8 you already have, but you also need to divide it by with the number of time intervals, which is 4. So this entire thing would be again divided by 4. So that would be your answer. So this is 4 plus 5, 9 plus 7, 16 plus 5, 21 divided by 8 times 4, which is 32. So that would be your answer, 21 by 32, which comes out to be, I think, 0.65625, or you can write it as 65.625%. So that's your average occupancy. So I hope this is clear. Now there is one more thing that you have to find, which is the parking load. So for that, okay, let me reduce this. this up. So for parking load, the formula is again straightforward, which is I think given in the slides itself, which is you have to find the area under the curve. So area under the parking accumulation curve over a given period of time. So that's the definition of parking load. So you can also write it as total number of vehicle accumulated at the end of each time interval multiplied it with time or the time interval. So now for the first time interval, 4 vehicles are accumulated. For the next time interval, 5 are accumulated. For the for the third one, 7 are accumulated, and for the fourth one, you have 1, 2, 3, 4, 5. Yeah, 5 of them are accumulated, and each of this time interval of 15 minutes, which you can convert it into hours. So this you can write it as 4 plus. Then you have 5 of them are accumulated for the next one. Then you have 7. Then you have 5. This multiplied by 15 minutes, and you have to convert it into hours. So that's why you are dividing it by 60. So which is 4 plus 5, 9 plus 7, 16 plus 5, 21 divided by 4. So this will be your vehicle hours. So this comes out to be 5.25 vehicle hours. So this will be your parking load. Again, this is, I think, similar to one of the example problems that have been solved in the slides as well. So you'll find it there. So this problem was pretty straightforward, but I think in the slide there was some mistake while calculating this parking, I think, load in the example. I think not in this example, but probably in another example where it has had to be multiplied with say, one number 5, which is the time interval, but it was multiplied with some other column value. So check it out. I think slide 33 in the lecture had some error. But anyway, for this problem, this is the answer, and this was like straightforward. So any doubts related to this? Otherwise, I'll move to the next problem. So let's move to the next one, which is one matching type problem. Not numerical as such, but anyway, it's easy to solve. So here I'll create a table. This is column X. We have to match it with column Y entries. So the first one is primary. So this is related to the traffic safety portion now. This is primary crash data source. For the next one, it is safety and it's surrogate safety measures. The second one is a reactive approach. Fill this up first. This proactive approach. First one is secondary crash data source. Then you have record from insurance companies. You have police reported crash database. One more thing I didn't add here in is and road safety audit is crash severity. So you have to match both these columns. Again, if you have gone through the slides, it should be pretty straightforward. It should be in, I think, in the second module of that, second lecture of that module, which is on traffic safety. So there, I think you'll find all this within a picture or a table was there. I think a diagram was there. There, all this classifications and everything there of the reactive and proactive approach as well as the data sources. So what would be the answer to this? You can try it out and then I'll give you the answer. Okay, so for the first one, primary crash data source is actually police reported crash database. So that's, you can find it from that diagram as well. So this is straightforward. Reactive approach relates to the crash severity models. So once the crash happens, after that you will react, and that comes from that severity models and so on. So this would be D. For the third one, proactive approach. So this doesn't necessarily mean that a crash has already happened. So this is kind of a surrogate safety measure, and road safety audits are used for proactive approach. So this would be A. And for the last one, as you can guess, secondary crash data source is, say, record from insurance companies. So this would be B. So this was very straightforward. So now let's move on to the next problem. Let's see. It's there in the, okay, so we have now a bunch of true false type problems again. So let's solve it in the next slide. State true or false. The first one is road environment related factors are least responsible for road crashes. Second one is, as per WHO global plan, the target has been set to reduce the number of road fatalities and serious injuries by 50% within 2030. Third one is adequate post-crash care facility has an impact on crash occurrences. Last one is MORTH defines black spots as sites with 5 road crashes or 10 fatalities in past 5 years. Okay, so what would be the answers to this? You can try this out. Give me the answers in the chat. Let me add one more here. So the aim of sorry, road safety engineering is to eventually bring down the number of fatal crashes to okay, so the answers. The first one is about road and environment related factors are least responsible for road crashes. Actually, you will find one diagram in the within this road crashes module, and there the contribution of those different factors are there within a pie chart, I think, and there I think you'll find out that vehicle related factors are actually the least responsible for road crashes, not the road environment related factors. So this would be false. One is not true, it's false because it's vehicle related factors. Okay, so two, okay, it's three false, four false, five true. Okay, let's see. So yeah, first one is actually not true. This is false. For the next one, as per this WHO global plan, the target has been set to reduce the number of work fatalities and serious injuries by 50% within 2030. And this is straightforward from the slides. This is actually true. This third one, adequate post-crash care facility has an impact on crash occurrences, which is false because post-care facility has nothing to do with crash occurrences. It's just only a measure after a crash has happened. So this is false, as you mentioned. Fourth one is this defines black spots as sites with 5 road crashes or 10 fatalities in the past 5 years. Actually, if you go back to the slides, it's not in past 5 years. This is in past 3 years. So this is false. And the last one, the aim of the road safety engineering is to eventually bring down the number of fatal crashes to zero. That's actually true because we know that it cannot be brought to zero but in ideal scenario, that's the goal of road safety engineering. Okay, so just, yeah, that's 3 years. That's correct. Yeah. So these are the answers to this. So this is straightforward. Now let's move to another numerical, and this is I think related to on-street parking. So let's solve that in the next slide. So first I'll give you the data. So this tells you presently 5,000 cars are parked on street in a CBD. There is no parking charge. The outcome from the parking beat survey is as follows. Table. So this will give you the duration of parking in hour. Then you have percentage of vehicle. So this is 0 to 1. This is 20. From 1 to 2 hours, 25% vehicles are there. 2 to 3, 30 vehicles are there. And so this is a 4 hours data. 25% vehicles are there. So now, let me write down the rest in here. So, study on all the present car users in the CBD indicates that the probability of bringing cars in the CBD may be expressed as this P of capital X equals 1 minus 0.015 times capital X, where P of X is the probability of bringing car when a total of rupees X is to be paid towards parking charge. So what will be the expected parking demand if a parking charge of rupees 10 per hour is implemented. So that's your option. So you can take a photo of this data and start solving. I'll solve it in the next slide. So straightforward, like the duration of parkings are given at every 1 hour interval. Percentage of vehicles are given. Total vehicles are 5,000. So from that you can get the actual count of vehicles within those intervals. Now it depends based on this. So your X is 10 here. So if you plug in 10, so that will give you probability of bringing a car when a total of rupees 10 to be paid towards parking charge. So you'll get the probabilities across different time intervals based on what is the like parking charge or the probability of bringing a car. So I think a similar problem was there in the lecture as well. Let me just quickly check. There in the slides, just one thing you have to be careful that so for 1 hour, this is 1 minus 0.015 times x. X is 10. But if we are in the second hour, then it's 10 times 2 because now this per hour charge were 10. But if you are parking for 2 hours, so that would be the probability of bringing a car when rupees 10 per hour is implemented in the second hour. So that would be the thing. So let's see. Why- 1 minus 0.04x. Oh, the problem data is different here. It's not like whatever it's there in the assignment and solving it. The expression can be anything. Yeah, in the slides, I think it was 0.04. So that's another thing. Yeah, you can try to solve it. minutes. I'll wait for a few more minutes and solve this. Okay, so answer is 0.6. Well, no, answer is not 0.6. How did you get 0.6? Can you explain? Because this asks you expected parking demand. 5,000 is the original demand. Now your expected parking demand is being asked. So it shouldn't be a fraction. It should be a like whole number. 0.6 is not at all correct. Okay, let me solve it in the next slide. But yeah, how did you come across 0.6? If you can explain that, it would be good because I'll be able to understand that why you are making this statement. Okay, so let me create another table, the next one. So there I'll write down all those values. So let me create table. So the solution is, so first is this duration of parking. This is an hour. Then you have, so this is 0 to 1, 1 to 2, 2 to 3, 3 to 4. Then you have percentage of vehicles. This is 20, 25, 30, 25. Then, so your total number of cars is 5,000. Now you can find out number of vehicles from here. So this is 5,000 times 20 divided by 100, which comes out to be 1,000. Similarly, if you take the 25%, it will come out to be 1250. If you take the 30% of this 5,000, it will come out to be 1500. And again, 25% is this. These are the number of vehicles. Now, probability of parking. So this, I'll write it as probability of parking. So this, the expression here is 1 minus 0.015 times x. So this is 1.015 times x is 10 here. So the first hour it is 0.85. For the next hour, so for 2 hours of duration, so this is 0.015 times 10 times 2. This will be 0.7. Then it's 1 minus 0.015 times 10 times 3. This would be 0.55. This is 1 minus 0.015 times 10 times 4, which is 0.4. And then you will have expected parking demand. So here you had 1,000 vehicles, out of which probability of parking is 0.85. So multiply this and get 850. Here it's 1250 times 0.7, which comes out to be 875. Then you have this 1500 number of vehicles times the probability, which is I think 825. And then finally you have 1250 times 0.4, which is 500. So now you're asked what will be the expected parking demand. So this is or the total expected parking demand. So you have to sum all those values for this. Okay, total expected parking demand equals 50 plus 875 plus 825 plus 500. So this will be your answer, which is uh, yeah, 3050. So it shouldn't be a fraction. So this is your final answer, 3050. Okay, hope this is clear. Then I'll move to the next problem. So let's solve another one. So we have again a true false type question. Then I'll move to the next one with a numerical again, but let's solve this one first. So the first one is crash frequency method does not consider the severity of crashes. Next one, yeah, yes. Okay, is it fine? And move to the next one. Yeah, so the next one is as per MORTH report, most of crashes in India occur due to red light violations. Third one is visual rating of a person is important as it plays a crucial role in deciding the color of traffic lights. Then we have the fourth one, which is increased parking fees may help to bring down on-street parking demand. So these are your four questions. So try this out and you can tell me the answer in the chat. So the first one is crash frequency methods. This is true because it doesn't take the severity into account. Okay, so true, 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 false. Okay, let's check. Okay, crash severity, crash frequency method does not consider the severity of crashes. That's true. So there we don't classify these crashes as severity. It's only the total count of crashes that's important. For the next one is as per MORTH report, most of crashes in India occur due to red light violations. This is actually not true because most of these crashes in India occur due to overspeeding. So again, you will find it in one of the I think figures that are there in this module. So there, the main cause is shown as the overspeeding, not like red light violation. So this is false. Then this visual acuity of a person is important as it plays a crucial role in deciding the color of traffic lights. Again, it's not true because it's not in deciding the color of traffic lights, it's the placement of traffic signs. So this is false. Still find it in the slides itself. Its visual acuity has nothing to do with color. It's the field of vision and those things are important here. And then increased parking fees may help to bring down on-street parking demand. So that was true. So yeah, this is the answer. So these were discussed in the lectures. So if you go back to the, yeah, go ahead. Sorry, it's like the color distinction is not nothing to do with visual acuity. So that's what I meant. So visual acuity is like relates to field of vision. That's why the placement of the signs are important, not the color. So I think if you go back to slide, I think let me check what slide is it. So yeah, so visual acuity and field of vision. So I think in slide 19 or slide 100, whatever you open in that this week's content, this vision characteristics are mentioned, and this visual acuity and field of vision. This is a key criteria in determining placement of traffic signs. Color vision is something which is different. That is key criteria in determining color of traffic signs. So those two are different things. So that's why it is false. So if you go back to the slide, you will be able to see. Hmm. No, no. Increasing parking fees. So this was again discussed in the I think lecture. There. So if you want to park it for a long duration, so there are two different things. One is one on-street parking and other is off-street parking. Now, what happens is that people who wants to park for longer duration should move to off-street parking. But if the fees are not that high, then they might also go for on-street parking because there are easy, like you don't have to move to another location to find those parking spots and so on. But now if you increase this fee, this you can bring down this on-street parking demand. So that's why it is true. So there are subtle difference between on-street and off-street parking. Yeah. So yeah, if you go through that lecture again, I think it will be clear to you. Uh, okay. So yeah, I think I'm not sure whether it was there in the slides directly, but it was talked about in the lecture itself. So I'll listen to it later. But okay, so I think this is about this problem. So now let's solve few more numericals. I think those are relevant that you might find in the assignment. So the first one is, I think, related to this EPTDO method and black spot analysis. So let's solve that numerical. Okay. So this is, I'll give you the data again. So consider the following crash data Lewis. Identify three, sorry, the most hazardous locations, or is called as black spots as well, using EPTO method. So I'll give you the table, then you have to find this out. Fill this table. So this is location, then you have different classifications of accidents. So this is fatalities. Sorry. Then you have major injuries, some minor injuries, and then you also have low injury crashes. Okay, so let's fill this table up. So we have location A, B, C, F, G, H, I, J. So there are 10 locations. For this location, fatalities are 1, 2, 0, 1, 3, 0, 1, 0, 1, 2. For this one, it is 2, 4, 8, 4, 3, 3, 0. Then you have 1, 3, 10, sorry, 10, 3, 7, 1, 0, 0, 2, 4. Finally, no injury crashes are 0, 2, 4, 3, 0, 14, 16, 8, 5. So you have to find the three most hazardous black spots using the EPTO method. So this is your data. So for that, what you have to find is this EPDO you have to find using a formula that was, I think, given in the slides, where different factors have to be taken for different types of accidents. For fatalities, I think it's 33. For major injuries, it's 15. Minor injuries, I think it was 1.16, and no injury crashes at like 1. And then you have to take the weighted sum of all this, and the one that those are the top three weighted sums that are highest will be the one that will be your answer to this problem. So you can try this out. First, you can take this data, then I'll solve it in the next slide. So, see. So EPDO method, I think it was discussed towards the end of this week's discussions. So yeah, I think a similar problem was also there in the slides itself, so shouldn't be too difficult. So this is equivalent property damage only method, which is called as EPDO. So let me solve it in the next slide. But first, or I can do it here itself. Let me check. Let's move it to the next slide itself. Better to add another column here. Option. Solve it in the next slide. So let me solve it. So first I'll get one table. Let's see if I can copy this increase. Made a mistake. I'll need another column. Sorry. Okay, so now I'll have the EPDO written here. So finding EPDO is not that difficult. So you have to just take the weighted sum of those things. So I'll just make this here. So the first one, so the formula here is that 33 times fatality plus 15 times major injuries, which is 2 for this. And then you have 1.16 times minor injuries plus 1 times no injury crashes. So that will be your answer. So here it comes out to be, let's check, 64.16. Similarly, you have to find for every other uh, locations the CPDO value. So now for the next one, so it's the same formula, 33 times 2 plus 15 times 4, then you have 1.16 times 3 and 1 times 2. So the next one would be 131.48. The C one is 33 times 0 plus 15 times 8 plus 10 times 1.16 and then 4 times 1. So this is I think 135.6. Similarly, this one is 33 times 1 plus 15 times 4 is 1.16 times 3 plus 3. And I think if you populate all this, let me check if I can calculate it. Let me calculate it itself. So next one is 33 times 3 plus 15 times 3. Then you have 7 times 1.16 and 1 times 0. So this is 152.92. For the next one, first term is 0, then you have 15 times 3 plus 1.16 times 1 plus 2. This is 48.16. Next one is 33 times 1 plus this is 15 times 2 plus 1.16 times 0 plus 14. So this comes out to be 77. Next one is, so you have only 15 times 2 plus 16. So this is 46. Next one is 33 times 1 plus 15 times 1, 1.16 times 2 plus 8. This is 58.32. And the last one is 33 times 2 plus 15 times 0. Then you have 1.16 times 4. And then you have plus 5, which is 75.64. So from here, the top three are this E, this C, and we have this B. E, C, and B. So those will be your top three. So let me check if the answer is correct. Yeah. Okay. So your answer is, so the top three are E, C, and we have B. So those are your top three black spots. So hope this is clear. Then I'll move to another problem. And this is an in-out survey. So again, it is related to the, I think, lecture content only. So this one is from an in-out survey conducted for 30 minutes at a parking area consisting of 80 bays. The initial count was found to be 65. The number of vehicles entering and exiting the parking area for a time interval of 5 minutes are shown on the table. The table I'll give. It has time. This is in minute. So this is in, out. This is 5, 10, 15, 20, 25, 30. This is 2. This is 11. This is 5, 9, 12, 6. Then you have 6, 4, 2, 9, 3, 9. So now you are asked is again you are asked two questions. So I'll write down the questions here. Then you can take this picture of this data and solve it in the next slide. Okay, so the first one is what is the average parking occupancy of the parking area? That's one. And the second one is what is the total parking load of the parking area? This is slightly different from the number plate method that we see before. So, yeah. So this is your problem data, and you have to solve this two problems. So I'll pause for a couple of minutes, and then we'll get started with this. So let me solve it on the next slide. So we'll create a similar table there. It's 7. So let me copy this problem data. So there are two things. One is occupancy, another is parking load. So there's two things we have to calculate. So here we'll check for occupancy. Here we'll check for parking. Oh, in fact, I should have created one more table, one more column. Sorry. Just delete this. So, six. First, we'll calculate accumulation because initially there were 65 vehicles, and then this in and out thing happened. Then occupancy, and then parking load. All right. So the initial accumulation was 65, and then what you had is two vehicles came in and six left. So then the accumulation would be 61. Right. So for the next one, you have 61, 11 comes in, 4 goes out. So we are left with 68. For the next one, it's 68 you have already, 5 comes in, 2 goes out, and you're left with 71. After that, it's 71 plus 9 and minus 9, so it remains as 71. Sorry. Then you have 71 plus 12 minus 3, so 80, and 80, there are total 80 bays, so this is fully occupied. And then finally, you have this 80, 6 comes in, 9 goes out, and you are left with 77. For occupancy, let's express it in percentage. So this will be 61 times 100 divided by 80, because there are 80 bays, right? So let's some space here. So this comes out to be, I think, 61 times 100 divided by 80, 76.25. For the next one, there are 68 of them. So this will come out to be 85%. Then you have 71 of them. This comes out to be 88.75. Then again, it's the same, 88.75. Then you have 100. And finally, you have 77. Of them occupied. So this is 96.25. So you have found the occupancies, and we'll see how to get the final answer. But for now, let's fill the table. For parking load, it's nothing but accumulation times the interval that you have. So it's 61 times. So that's what I meant. In the slides, I think there was some mistake here. I think it is multiplied with this column, but actually it should be multiplied with this column. So this comes out to be 305. For the next one is 68 times 5, which is 340. This one is 71 times 5, which comes out to be 355. This is also 71 times 5, which is 355. Finally, this is 80 times 5, which is 400. So these are in, the units are in vehicles minute. Vehicles minute. And then finally, you have 77 times 5, which is 385. Now, there were two questions. One of them were, what is the average parking occupancy? And the last one is total parking load. So for the first one, you have to take the average. So let's take, first one is average parking occupancy. So this is 76.25 plus 85 plus 88.75 plus 88.75 plus 100 plus 96.25, and there are 6 such intervals, so divided by 6. So it comes out to be, let's calculate. 175 plus 100 is 96.25. 6, it's 89 point, I think 17. This is in percent. And the next one is total parking load. It's just adding up that column. This is 305 plus 340 plus 355 plus 355 plus 400 plus 385. This is in vehicles minute, and it comes out to be, let's check. Okay, I'll just calculate it. So this is 305 plus 340 plus 455 plus 255 plus 400 plus 25, 2140. Okay, so this is your answer. Okay, so I think I've covered most of the things that you'll find in the assignment. So maybe I'll just quickly open the assignment and check if I have missed anything. Okay, so let me open the assignment. So if you can see, so in assignment 11, the first question tells you, so parking occupancy surveys are useful in determining long-term parking demand. I think we have seen one similar to calls today. So you have to read that portion where the short-term parking demand and long-term parking demands are written, and mostly I think it was related to the beat surveys. So you can guess what would be the answer to this. So it should be straightforward. Next is, I think, this license plate method and the problem related to that I have already solved. This parking turnover I solved it as well. Data might be slightly different here than what I used, so you have to be careful in that. So the answer won't be exactly the same. Average occupancy percentage, I think this is also I have answered it today, like not for the same problem, but slightly different data. And then parking load also, that was also discussed related to this discussion. So this first 4 questions I think I've already discussed, shouldn't be too difficult to solve. So let me check. Yeah, this should be straightforward. Fifth one, again, I think I solved a similar problem where this reactive proactive approach. So those were there in the column X instead of Y. This primary crash data source, secondary crash data source, and this police crash report, hospital crash prediction models, interview approach, users, and safe system approach. All this you'll find in, I think there are a couple of diagrams in that module, and there everything is listed down like a flowchart kind of thing. So you'll find it from there itself. Shouldn't be too difficult to solve. Then which of the following statements is incorrect? So this one I think I have already discussed, the first one. Then the other ones, I think, yeah, this last one I think I discussed as well. There it was slightly in a different manner. I think environment was written, road environments and so on, but here is vehicle related factors. The other 2 sequences of events or the reactive approaches require historical crash data. If you go through the slides, you'll get the answer. Shouldn't be too difficult as such. The 7th one is again similar to what I solved today in the class, but here it's the final expected parking demand. We found that out, that is given here, which is 2560. And in the earlier problem that I solved, there this value of x was given as 10, but here it is an unknown. So this here it's x. So you have to keep this as x, and in some other places it will be 2x, 3x, and 4x. And based on that, you have to find the expression for expected this parking demand in terms of X, and then you have to equate it to 2560. Then if you solve that equation, you will get the value of X. So that would be the idea here. It shouldn't be too difficult. So this is related to parking beat surveys. Again, it's directly from the slides. If you read, you will get the answer. It shouldn't be too long. Next is, I think, the definition of parking occupancy. This has been already discussed today. Visual acuity and field of vision, this I have already discussed. So this raised pavement markers impact daytime crashes. So you have to check whether it's daytime or nighttime. So I only discussing it in detail here. And then this overspeeding thing, I have already discussed it in the class. It was something else there, but here it's overspeeding. Then this problem with the CPDO method, it's very similar to what we solved today. I think the data might be slightly different, so you have to check what would be the correct answer. But the formula and all remains the same. You have to create another column with EPDO and just do those calculations and you will get the answer. Last one is total crash count method. Consider severity of crashes. I think this was also discussed briefly. That doesn't classify anything as such in crashes. So this assignment is very simple, I think, and everything have been discussed in the class. So any doubts related to this assignment, you can ask. Otherwise, like, I think I've solved most of the things today. So any doubts related to the assignment or the discussion that I had today? Uh, Otherwise, I think I'm done for this session because I've covered all those aspects that are there in this. Software as such for simulation, or do you mean something else? Yeah. So there are different softwares like Sumo, Vissim, those are traffic micro simulation softwares. So I think those are not discussed here in this course, but it's better to learn those things. Yeah, in the future, if you learn, that would be helpful. But yeah, these are not discussed here. Like Vissim, Sumo, these are not part of the discussion here. So there you can create your own models, like for parking simulation and everything. You can give the inputs there, and then the simulation will run for it. So it's not very straightforward. There is a lot of learning curve involved, but yeah, it's good to learn. Okay. Anything else? Okay, I'll probably wait for 5 more minutes. If no more questions, I'll close the session after that. The discussion is done. So in the next week, I think there is some, I think what's there? Yeah, this crash data analysis, the safe system approach, and these things are discussed. Speed management measures. So that would be next Tuesday will be the last session for this course. Yes, the recording will be available tonight. If no more questions, feel free to leave the meeting and close the session for this week.